Hello, and welcome to day 2 of the software engineering workshop at the Teens in AI Accelerator. Today, we're going to talk about source control. So what is source control? Well, mostly it's a way of keeping your source code safe. It's a combination of practices and tools that allows to keep your application source code files backed up in a safe place, but also protected against accidental or even malicious damage. It's a way of actually storing every version of every file you've ever worked on a particular project and be able to go to it if you need to. So we call the feature time travel. You can literally, the source control is also called version control because it stores specific versions of every file and also the version of the release, which is a sum of all the files for a particular version. And so when you say I want to go back to my product's version 1.0, it knows exactly what versions of every file made at that version, and then you can go back in time, literally, and rebuild that version and look at it. If you know that there was a bug in that version, you can literally go back and correct that issue and then reissue a version 1.01, for example. So it's a great way to actually allow you to keep track of everything you've ever done. One of the big features of source control is the fact that it allows you to collaborate with teammates. As we'll see in a little while, if you go from a local source control system to a more cloud-based control system, you realize that you can then start sharing that code base across a lot of people. And that allows people to work on the same code base at the same time. And that sounds a little bit counterintuitive. And in the old times, we used to actually lock files so that only one person at a time could work on it. That's long gone. And now we actually can collaborate, work on the same bits of code, and then do some clever conflict resolution, which we'll talk about in a little while. Is basically a way to act as the gatekeeper of the project source code and allows people to work on different areas. It allows people to exchange ideas, to do changes and propose them to the rest of the team, and they can actually then do what we call a code review, make sure that what you've done is right, it fits the way that the team works, it fits the product, it fits, it doesn't have any issues, and so then people will accept that and put it into the next version of the software. And as I said before, the one way that we track what we build and what product represents is the versioning of that product. And so if you're in version 2.0 and you suddenly realize that every user in version 1.5 and above had a bug, you can literally go to source control, retrieve version 1.5, look at the bug, fix it, and reissue a patch on that particular version that allows people to continue to use 1.5 or with the fix, as well as carry that fix forward to 2.0 and above. So it's a very fascinating subject. It can get quite complex because as software becomes complex, so does its source control and the code base that you use to build it. And so you have to be aware that it's a very powerful tool and allows you to do a lot of things. So there are quite a few control systems that have evolved over time. Here they're listed almost like from the current one to the old one. So Git is by far the most popular. It's used by a lot of people as a distributed version control system, which I'll explain in a little while. And that makes it the most flexible, the most useful in terms of its features. Before Git, well, not before Git, but competitor Git early on was TFS, which is a system designed by Microsoft, but it's currently being phased out in favor of Git, precisely because Microsoft actually acquired one of the biggest Git providers, GitHub, and is moving everything that they have onto the Git system. SVN was a precursor to Git. It was the sort of centralized version of the version control system. So instead of being distributed like Git, it needs one central server where everybody goes to get the latest version of the code and work on it. And unfortunately what that means is that you need to do that sort of file locking I was talking about before. So only one person at a time can work on one particular file of the code base. And then the CVS, which I call the granddaddy of version control systems because that was one of the very early ones. I remember working CVS 20 years ago, and that was the way that you did source control at the time. It was one step above from not having source control. It was very strict, very cumbersome to use. And some companies probably still use it because they have really, really old legacy code that's still stored in CVS. And so they probably still need to have it around. It must be a nightmare, and I don't envy them. So of all those control systems that we've seen, why Git? Why is people choosing Git? What is special about it? Why are we moving to it? Well, it's definitely the most popular version control system. You can see 70%, an estimated 70% of all projects currently are stored in Git source control systems. And now there's different providers that provide Git technology, so that doesn't mean that they're all under one single provider. But everybody, or about 70% of the projects out there right now, have chosen to be controlled in Git, which tells a lot about the quality of the system. One of the great advantages of Git is that it works everywhere, and I mean everywhere. I mean there's versions of it running on Windows, on Linux, on Mac, on things as small as the Raspberry Pi. You can literally use it on any operating system on almost every device. There's lots of user interfaces for it, and they have evolved, and you can connect all sorts of funky visual tools to actually use Git. Git by default is we've got a command line interface. So basically you have to use your terminal and type in lots of commands, and we'll see a bit of a demo of that in a bit. But there are visual interfaces that if you feel more comfortable with, you can easily jump on. As I said before, it's a distributed system, and the big difference between that and the older centralized systems is that they every single developer that's working on Git has a copy of the repository. And what I mean by repository is basically the code base that the team is working on. And so your laptop or your PC will have a copy of the repository up to that point. When you retrieve it, you'll have every single story, every single piece of code that was written since the project started. And then you can work on it on isolation, and nobody else will see those changes until you decide to share them back to the main centralized server. And at that point, it becomes available to everybody else. So the difference here is that every single laptop becomes almost like a safe of the code. So even if a big server caught fire, there's a version somewhere on someone's laptop that you can retrieve the code from. So it gives you that much more power and flexibility. And obviously, one of the big things about Git is that it's both very secure and it's high performance. Secure in that it's designed to maintain the integrity of the source code, so you will never mess it up. You can always go back in time, as we said, but also power up the code and the objects that you upload to it. And it's all secured cryptographically, so it means that if someone breached a remote repository or a laptop repository, it'd be encrypted, so they would have a very hard time actually getting access to the source code. And also it's been designed to be high performance, so that lots of people can work concurrently on them. It actually puts very little demands on the servers, because as I said, most of the work happens on your laptop, and only when you do merges and synchronize back to the server is when you get that sort of interaction with the main centralized system. So in order to get started, I want to describe a few concepts that explain what Git does, and the terminologies that you need to understand before you actually start working on them, purely because otherwise you're going to get confused with the demo that follows. So let's go through them. Repository, as I said, is basically the location of the source files are stored in. So that's basically where all the code base that you write or that you will write will sit. And so when someone says, I want to go and work on your project, you have to point them to a repository, and that's how they get started. We use the expression remote to mean like the remote version of the repository. So you'll have a local version on your laptop or your PC, and then there'll be one in the central server somewhere, in a remote server, which is where things get backed up in the cloud and makes it safer to protects against loss of your laptop, etc. And we call that remote. Trunk is the most current stable version of the source code, and generally that matches up with the current release build of your product. And if you think about it, we're going to think about Git as a bit of a tree. It has a main trunk, which is where the main code base sits, and then there'll be branches coming off it, and that's where the next concept is, the branch. Effectively, a branch is a working development version of the trunk with the changes, updates, and modifications that any specific developer may have want to do. And so basically, when you need to build a new feature for your product, you can literally create a new branch of the main trunk, do your thing, and then when you're happy with it, you can merge it back into the trunk. And so it allows you loads of developers to work on a variety of changes to the main trunk without disrupting the tree itself. A commit is effectively when someone has worked on a bit of work on a task, they can commit that back into their branch. So basically that means that until you commit it, that those changes are invisible to Git. So if you haven't committed and you lose your laptop, you lose your code. The idea is let's do some changes. I'm happy to put this back onto a safe store. So I do a commit, and that goes into safe store. And at that point, that commit will only be in your laptop. Then you have to do something else I will cover in a second. That's cloning. Cloning is when you join a team from the beginning, and well, you join a team that's been working on a project for a while, and they basically say, okay, to get started with a product, you first have to clone the repository. And so what you'll do with Git is do a Git clone, which goes to the repository, downloads every single file and object that's ever been in the repository, and it puts you on an even kill with the rest of the team. Now you have a repository that's a copy, a clone of the original repository that's stored centrally. Merging is something that comes from the branching part. So when you've branched away from the trunk and you've done your changes, what you then need to do is to put it back into the main trunk. You have to merge, and what that means is that it merges your source code with the existing source code in the trunk. And at some times you may have changed something that another developer may have also changed at the same time, in the time that it took you to branch out, change code, and remerge. And so Git sees that as a conflict, because two people have changed the same bit of code at the same time. And so basically what it'll do is it'll give you a very intelligent opinion as to what the fix could be, but it will ultimately leave the human to decide what bits of the code from your colleague as well as yours get merged together into the final version. Once we've done the commits, what we need to do is push that code and those objects back to the remote. What that ensures is that the commits don't just stay in your laptop, but they actually go into the central repository. That's basically what keeps your code safe against loss or theft of your laptop, for example. So if you're really, really working on something very important, you spend a good day's work doing lots of cool stuff, you don't just want to commit, you want to push, because that push will make sure that that code is safe away from your centralized, from your local computer. And then pull is almost the opposite. It's basically, okay, I did a clone a while ago, I haven't actually been active on this repository for a while, and I'm sure there's been changes to it. So what you do is you do a pull, and then Git will actually look at the remote repository, look at the changes that have been from the version you have to the new version in the main trunk, and it will download those. It could be the main trunk, or it could be the branch that you're in, it depends on where you sit. But effectively, it just resynchronizes your local repository to whatever is in the remote. And a pull request, this is an interesting one, and we'll see a demo of that in a little while, is when you've merged your branch into the master or into another branch. It will basically ask you to create a pull request, which means that someone else in your team has to look at your changes, look at how they would affect the main trunk, and then accept that pull request. If that pull request gets rejected because the coding standards haven't been met, or because they detected a bug, or give you comments to correct things before you get accepted, then you go back, change your code, and then resubmit. If it gets accepted, then it basically gets automatically merged to the main trunk or the destination branch, if that's what you're doing, and then your code is now part of the main release. Okay, so before we get started with the stuff that I'd like to do today, I want to make sure, and I know I mentioned this during the introduction video, I want to make sure you have the right ingredients on your laptop to follow this process. So make sure you install Visual Studio Code, and there's your link. If you haven't done it already, please go and download it, and it will work on Windows, Linux, Mac, whatever you have. So don't worry about it not being available for your platform. Then you need to install Git. Now, the Windows way to install it is basically go to this and download. There may be better ways to install it on Linux with an apt-get or something like that. So if you're a Linux user, you should already know how to install Git. If you're a Mac user, you can also go to this link and it should work. Then make sure you create an account on GitHub, and we'll go through that in a little while. But basically, GitHub is what's going to act as our remote Git repository storage. So basically, once you have GitHub, it's free, you can create it, and then you can store all your projects there for this workshop, as well as whatever comes next in your career. We use it all in professional life, so it's one of the most used Git repositories out there. And then if you're in Windows, and this is for Windows users only, you will need to interact with Git using the command line interface. Now, you can use a really old command line interface that comes with Windows, but now with the advent of Windows Terminal for Windows 10, you can actually do much better. And so I recommend, if you do have Windows, you go to the Microsoft Store app in your computer, look up Windows Terminal and download it and install it, because we're going to make good use of it. So let's go through some of the examples of how you use Git, and you can either follow along on your computer at the same time and pause when you get stuck, or just watch the whole video and then try to do it yourself. See you on the other side. And now comes the fun part. Before we start, let me show you what we have on the screen. We have GitHub open here, which I hope you have created an account for. If not, feel free to pause the video and get through that. You go to github.com, register, and you'll get a free account straight away. Then I have Visual Studio Code, and that's available in all operating systems. So you can get that on Windows, you can get that on Mac, you can get it on Linux, and it's a great editor and IDE in general to be able to code and do all sorts of funky stuff. And then I have Windows Terminal. I'm using Windows, so I'm using Windows Terminal, which you can download from the Microsoft Store on Windows. If you're using Mac or Linux, you can use the terminals that already come out of the box with that system. So I've already gone into sort of a directory that I think is where I want to base all my repositories for demos and things. So I've created a projects folder. Inside that, created a TeensInAI folder. So the first thing we're going to do is we're going to create our first repo folder. So to do that in Windows, I just do make directory first repo. That's what I'm going to call it. And then I'm going to go into the first repo itself. Right. So now I'm inside a folder called first repo. The way in which you turn a folder, a standard Windows or Mac folder, into a Git repository is by calling the command git init. And of course, at this point, I expect you have installed Git already. If not, please pause the video and do that. You can see how in this particular terminal setup I have, it actually identifies the fact that I'm on a Git repository and is marked it as master. Master is the way that Git calls the main branch, the actual trunk of the source code, is basically where we keep the latest release that's going to be live in production, effectively, when you're building code. So that's the beginning of creating a repository. Now, if you see here in Visual Studio Code, it's already picked up that there's a new folder. So I'm going to open it and there's nothing there. So the first thing I'm going to do, I'm going to create a file. And that file doesn't need to be a code, it could be anything. So in fact, I'm going to call it hello text. I'm just going to make it a text file. And in that file, I'm just going to write hello git and save it. And I have a folder with a called first repo with a file called hello text. So in Git, if you want to know where you stand right now, there's a command called status. So if I say git status, that will actually tell me, oh look, there's no commits done yet, but I've detected there's a file that I don't recognize called hello text, which is in red. And you can see that my interesting prompt here, and I can show you how to do that in the questions later if you want, is telling me that I'm still in the master branch, but now I'm not the same as the master branch, which is basically the beginning when this is completely empty, the repository is completely empty. It's detected there's a new file, there are no updates, and there are no deletions. So it's detected something is in yellow because there's a change that you haven't actually committed yet, and so it's an addition of a file. So that's quite cool. You can see that Git is already telling us what's been happening inside its repository. Now, one of the very confusing things about Git, if you never used it before, is that the fact that you've done a change and you can see that it's red doesn't mean that that change is gone anywhere other than your machine. So if you're working with a team and there's a remote repository, which we will do in a little while, you'll notice that that repository has no idea that you've been working on this. And this is one of the beauties of Git. Every single developer has a copy of the repository, which holds the status for all the repositories up to that point, plus whatever changes you've done. So be aware that just because you've created a file here, Git, the master repository doesn't know anything about it yet. And so the way that we do that, the way that we change that red to go green, is to use the add command. And what that does is tells Git, I'm going to add this file to my list of things I want you to watch for. And that's git add, and then you give it the file name, in this case hello text. And if I do a git status now, you will see that it's green and it says, okay, we're in the branch master, there are no commits yet, but there are changes to be committed, meaning you've added something to Git that you want it to keep track of, called hello.txt, which is gone green. The status in yellow here, you still see that it hasn't changed, and that's because it's following the master branch, and you haven't actually synced up with the master branch yet, which we'll do in a while. And so it's telling you there's a change. So okay, now we have a file that's changed and that we've added to the repository. How do we actually then commit it? Well, simply enough, it's called commit. So if we do git commit, but then commit requires you to add a comment or message, which is -m, and then you put quotes, and then you call it whatever you want to say. And now, this is typical of developers to do this, just write rubbish. Never ever do that, because when you're working with a team, they really want to know why you committed a file, because you will have something called code reviews. Other colleagues will actually look at your code, and obviously these commit messages help them assess why you checked this file in the first place. What is it? What changes did you do that require you to add files to the system? And so never ever type rubbish, always type something meaningful. So in this case, I'm going to say our first commit. Enter. And now you can see it's gone green and there is no changes. Now we are defining master as what we have. There are no commits pending, there are no changes that haven't been committed. The repository is now clean with the one file that we've added. You can see that here. There's been one insertion and that's been committed to the repository, which is fantastic. Now, this is the very basics. Let me just clear so you can see where we are. This is just your basic, how do you add a file, edit it, and then commit the change. So now you know how to actually do file addition and a change and a commit into the repository. If we now go ahead and change this file that was already committed and say hello git again, save. If I press enter, I'll see that this is changed back to yellow. And this time it's telling us there's been an update. There's not been an addition because the file was already there. There's been an update. So if I do a git status, it's now telling me that file has been modified. Now, it's telling me what to do. If you look here, no changes added to commit. Use git add and or git commit -a. So you can do two things. You can repeat your git add hello text and that adds it back to the commit, another new commit. Or you can just do it all in one command and do git commit -a. So what I normally do after a file already exists is git commit -a and then m for the message and say my first update. And so this is gonna do both the git add hello.txt and the git commit my first update in one single command. There we go, it's gone green. And then you can see if I do a git status that it's all back to, nothing to commit, working tree clean. So there's nothing there. So let's clear again. And now what we're going to do is talk about branches. So we already see master is what we call the trunk. If you think about a tree, you have master, which is the main tree branch, the trunk of it. And you can see this little icon here. It looks like a tree with a branch coming off it. So what we as developers do normally is if you want to experiment or you want to build a new feature and you don't want to disrupt the main branch, what you normally do is you branch off into your own space. And what it allows you to do is basically it gets a complete copy of the repository, but then you can mess with it, you can add new features, you can do whatever, and then the main branch or the master branch remains unaffected. And you can do everything you need until you're ready to show people your changes. And at that point you do something called a merge, which we'll talk about in a second. But first, let's see how you create a branch in Git. So for that, we can do something that will both create a branch and check out that branch, meaning that my repository will no longer point to master, it will point to my new branch. So that's called checkout. I'm going to do a checkout, but I'm going to create the branch. The branch is going to be called my branch because, I can't be more creative today. There we go. So if you look at what happened, it created a branch called my branch and it said switch to a new branch, my branch. And you can see here, it's actually gone to my branch now. So we're no longer in the master branch. We're now in our own specific branch, which is always quite useful. So after running that, we can do something like git branch to actually tell us details about where we are. See, there are two branches. There's the master branch, and then the star tells me I'm actually in my branch, the green one, saying there are multiple branches, and this is the one you are currently set up to do. So that's good. That means that when I have a branch, it's copied the whole master branch across. So the minute the my branch and master branch are the same, there's not been changes. So let's just change here from my branch. Save. If I do enter, there we go. There's been an update. So again, let's do same thing we did before. My first branch update. There you go. So now my branch is back to green. It's had an update, but you will now in your heads realize that my branch and master are now no longer the same. So master continues to contain hello git again, and my branch contains hello git from my branch. So that's always worth keeping in mind. And now we're going to move straight to GitHub after we've done a little bit of Git. Now GitHub is basically allows you to do Git in the cloud. So at the moment we've been working with a local repository, which means that only your laptop has the information that you've just been playing with. GitHub allows you to upload this to the cloud for safety, so you have a copy somewhere else, but also because it allows collaboration across lots of different people working in the same team, which means that a lot of people can work on the same code base. Now, your GitHub, if you haven't done anything with it other than creating your account, will look slightly different to mine, but that's fine. What we want to do is go to the repositories part, and that's where we're going to create a new repo, and we're going to try and synchronize the repo that you have on your laptop that you just created with the one that we're going to create in the cloud. So if you go to this area, you'll see the green new button. It's difficult to miss. So we press that, and basically now we have to give the repository a name. Now it does say it has to be short and memorable, and hopefully the system will check whether the name exists already or not. If it does exist, it won't let you create it. So I'm just going to say my first repo, and hope that is free. There you go. It's available. Now you can choose to make it public, which means that lots of people, everybody in the world that has GitHub accounts can see it, or private if you just want to keep the code private to yourself. This normally works, this is how companies do it. So you create a private repository, and that means that only the people you let access to the repository will have the visibility of the code. You can create things like, initialize the README, things we might do later, but at the moment we're just going to leave it very basic. We'll make it public because this is just a demo, and I'll go ahead and create the repository. And what you'll see now, it gives you a few options. You can literally just clone this, and the term clone just means that you get into your laptop and you download the skeleton of this repo and then continue coding on your laptop, and then you sync them up. But what we're going to do, because we already created a repository ourselves, we're going to go this or push an existing repository from the command line. And funnily enough, it just gives you the commands you need to make that happen. So we're going to copy the first command. Now what might happen is in your laptop, if you haven't logged into GitHub before, it will ask you to log in when you do this. So, well, that's very quick. What this command does is basically is setting up an alias to the remote repository, which is the one hosted in GitHub, and that normally is called origin. And then it's given us the actual address, the URL for the repository itself. So as you see, it's made up of your username and whatever the repository name you chose, .git. And now what we're going to do is push our master branch to the origin, which is the remote repository. And when we do that, what will happen is the system will literally, as I said, see, we haven't logged in before, so it's asking us to log in. Now I can't even remember whether that's my password. Nope. And after I fix my login and password situation, you can see that after doing the push to the origin from my master branch, it actually synchronized it and it uploaded the files from my laptop up to the repository in the cloud. And now we synchronize the master branches. So both master branches are now the same. Now, that's all very well, but we've already created the my branch. And what we need to see now is how do you actually put that new branch up to the repository. Let's go back to code first. And here we go. See, I can show you that in the master branch, we have hello text, which contains hello git again. which is exactly what we should see. So let's go back to the repo, and then what we're going to say is, okay, how do we push our existing branch, not the master branch, but our existing my branch, to the repo? And that is very easy. I'm going to clear the screen so it makes it easy to see, and then use the command git push. So we're going to push to origin, but we're going to push my branch. And hopefully we'll see that it's actually looking at our local repository, and it's created a pull request for my branch on the repository itself. So let's have a look here, and there it is. And if we look at the hello text now, is hello git from my branch. So now we have both branches synchronized with the cloud in GitHub, and that basically shows us that we can have as many branches as we need. It's a very efficient system because the branches stay in your laptop or in your computer until you're ready to sync them up. And sometimes you might not even do that if you realize that branch is not good to you and you can delete it. And then the final sort of bit that I just mentioned is create a pull request. So to create a pull request, what it means, and this is it's not necessarily used when you're working on your own, but when you're working in a team, it's very important. And what that allows you to do is to create a request that tells your teammates that you're ready to merge your current branch to the master branch. And what that means is that you've created your new feature in your own individual branch, whatever name you've given them. In this case, is my branch. And then you're happy that what you've done should now become part of the main branch of the master branch. And to do that, normally you try to do it properly. You use a pull request. You could force your way into the master branch, but that's not the right thing to do. What you want to do is make sure that you share the fact that you want to do a pull request with your team. So if you look at here, what I've done is just refreshed, and you see the compare and pull request. So as easy as that. Because you've pushed a branch into the repo in the cloud, it's actually realized that you might want to do a merge with it. So if I click compare and pull request, you basically have to look at what you've done in terms of changes. And if you look down here, it's doing a very nice, we call it diff. It's doing a comparison between what was there before and what is there now. So it's realized that you've removed the word again and replaced it with from my branch. And basically it's just asking you to put some comment to let your team know what you've done. So in this case, replaced again with from my branch. Obviously it will be a more descriptive thing than that, but in this case we're just providing a bit of an example. Create a pull request, and now the system is doing something, saying comparing to the master branch and see whether there are conflicts. Now this is an interesting thing, because when you're working on the code together with other people, you may find that the code you change is also being changed by someone else in a slightly different way. The system will identify that and won't let you merge directly if it identifies that there's a conflict. And that conflict then needs a human to resolve it. So you have to look at the code you put in, the code the other person put in, and make sure that whatever ends up in the master branch is the right combination of the two. So you don't overwrite someone else's changes accidentally. In this case, because we created everything one after the other, there is no conflict. So I'm just going to merge the pull request, and that should now become part of, you can see that big merge logo there. And if we have a look at the repo, and we're now in the master branch, and look at hello text, now contains from my branch, even though that was originally in the my branch branch itself. Now, a good practice normally is when you finish with merging a branch, you delete it if there is no more life for it, because it's been merged completely into the master branch, so you can go ahead and delete that. We won't do that now, but it's something that you can easily do in here. Now to close the loop, what we want to do is make sure that in our laptop we're synced back up with the new master branch, which now contains what my branch used to contain. So a good way to do that is to pull, instead of push, we pull from origin into the master branch. So if I do that, git pull origin master. And basically what's happened is that we've retrieved whatever changes were, whatever commits were in the master branch that we didn't have before. In that case, we obviously have an updated hello text. But you can notice here that we're still in my branch, so we won't be able to see those changes. We will see whatever my branch had. So in order to actually get to see what's in the master branch, we need to move away from my branch and go back to master. To do that, you do a checkout like we did before. So checkout master. And you can see that it's red and it says there's 2 things to update. So if I do, let's do git status just to see what that is. If I do git pull, there we go, it's now retrieved it, sorry. So now we have an updated git pull, which contains the same content as before. As you can see, it's refreshed, but it's refreshed to the same because now master looks the same as my branch used to look like. And that is pretty much the major functionality of Git. There's a lot more functionality behind that. You can do a lot of things in conflict resolution. You can do a lot of things in automation. That's for a more advanced course. And of course, you can just go and experiment. I think that's something that you're going to find super interesting. And particularly when you start working on your projects and you have multiple people working in the code, GitHub will be a godsend because it'll allow you to work collaboratively on the code without trampling over each other's feet. So I hope you enjoyed that demo. And now we're just going to go to the end of the slides. Okay, I hope that was a useful demo of what you can do. And with that, let's go into our challenges. So today's challenges, I want you effectively to replicate what you saw in the video to a point. But I want you to be more free with what you do. So basically make sure you create a local repository in your machine. Try some of the Git commands that you saw in the video. Make sure that you then push changes to your GitHub repository and you know how to now tie up your local and your remote repositories through what you saw in the video. And then obviously just feel free to do changes, experiment, remember GitHub allows you to go back in time. So if you mess something up, don't be afraid. You can just do a get pull from the repository and you'll be back to where you were. At the same time, if you want to go away from just doing text files and start doing code, that would be awesome. So, start looking at that. And then if you want to know more about Git, where it came from, how it's used, on all the extra power that it brings that I didn't cover in the video, please do go to these links. Either of them will do. They're very, very good source of information on how to use Git to the next level. And with that, that's the end of day 2. So thank you very much for sticking around. And I look forward to seeing you tomorrow.